relativity rings the thin world smoothly curving around its round partner. In this picture, it embodies an inconceivably exceptional and very interesting event. This picture highlights Galaxy 0220-58s, arranged in the southern half of the globe, in the group of stars of Fornax, the Heater. It is the biggest and among the most over-the-top Einstein rings ever found in our universe. The lead researcher and their team, who are analyzing this Einstein ring, have warmly named it the liquid ring as a nod to both its appearance and its host star grouping. Such objects serve as perfect laboratories for researching galaxies too faint and remote to be observed otherwise. The blue dwarf universe NGC 5253, a blue compact dwarf, BCD, galaxy in the constellation Centaurus, is relatively close by, at a distance of around 12 million light-years. Generally, BCD galaxies are marked by regions of intense star formation activity and a high density of dust, though they contain fewer heavy elements compared to galaxies like the Milky Way. These galaxies harbor molecular clouds that are chemically and physically similar to those that gave birth to the first stars in the early universe, before the accumulation of dust and heavy elements. The BCD galaxies have long been viewed as ideal places from which to explore the origin of the universe's first stars. NGC 1275. This captivating picture of NGC 1275, captured by the observatory, highlights the exquisite clarity and resolution of the reddish, ribbon-like filamentary structures surrounding the bright central region of NGC 1275. Although enveloped by gas reaching temperatures of nearly 55 million degrees Celsius, these filaments remain cool. They demonstrate how energy from the central black hole is transferred to the surrounding gas while being held in place by a magnetic field. Cosmologists recently estimated the strength of the magnetic field by observing the filamentary structure. With this data, scientists revealed that extragalactic magnetic fields have preserved the filament structure over their 100 million-year lifetime, protecting them from collapsing under gravitational forces or disruption from surrounding matter. Able 1689. A glimpse into dark matter. The NASA/ESA James Webb Space Telescope provides a stunning view of the massive galaxy cluster Able 1689, which contains 1 billion galaxies and 1 trillion stars. This cluster exemplifies the distribution of dark matter, an invisible substance that makes up most of the universe's mass. While Webb cannot directly observe dark matter, astronomers have detected its presence through gravitational lensing, the bending of light from galaxies behind Able 1689 as it passes through intervening matter within the cluster. To understand the distribution and mass of dark matter in the cluster, researchers analyzed the positions of 135 lensed images of 42 background galaxies, creating a map with blue-tinted areas indicating the expected prevalence of dark matter. The lensing distortions would be significantly less pronounced if the cluster's gravity were due solely to visible galaxies. The map reveals the highest concentration of dark matter at the center of the cluster. Able 1689 is estimated to be approximately 2.2 billion light-years from Earth. Neptune's rings. This remarkable image of Neptune's rings, captured by Webb's near-infrared camera, reveals the planet's wild, turbulent atmosphere. The rings haven't been seen in more than 30 years. The ice giant Neptune has a higher methane content than the gas giants Jupiter and Saturn, and Webb's photo shows that near-infrared methane isn't blue. Methane absorbs red and infrared light, making the planet appear dark at near-infrared frequencies, except for high-altitude clouds. The image shows bright streaks and patches from methane ice clouds reflecting sunlight before being absorbed by methane gas. To the upper left of the planet, Triton, one of Neptune's moons, shows 8 diffraction spikes, a telescope artifact. Webb also captured 6 of Neptune's other 14 moons, a nearby star, and several faint galaxies. NGC 346. This image of NGC 346, captured by NASA's James Webb Space Telescope's near-infrared camera, features a young star cluster nestled within a cloud situated 200,000 light-years away. Webb reveals a more abundant supply of building blocks than previously thought, including dust and hydrogen-rich clouds that contribute to the formation of stars and planets. The gaseous plumes and arcs in this image contain both molecular and atomic hydrogen. The pink gas represents energetic hydrogen, reaching temperatures up to 18,000 degrees Fahrenheit, while the orange gas represents cooler regions. Thick subatomic hydrogen, a lot colder at temperatures of minus 2,200 degrees Fahrenheit or below, is joined by the natural dust found nearby. As stars emerge from the cooler gas, they change their surrounding environment. The various edges visible throughout the image showcase the effect of light from these young stars as it filters through the dense clouds. The glowing gas pillars represent the broad effects of this celestial activity. The Lagoon Nebula, a vibrant and mesmerizing image found about 4,000 light-years away, spans a remarkable 55 light-years in width and 20 light-years in height. The image captures just a small portion of this turbulent, star-forming region, which covers an area of about 4 light-years across. The Lagoon Nebula was first recorded in 1654 by Italian astronomer Giovanni Battista Hodierna, whose goal was to catalog amorphous objects in the night sky to avoid confusion with comets. Since Hodierna's initial observations, the Lagoon Nebula has been photographed and studied by numerous telescopes and astronomers worldwide. Using near-infrared cameras, astronomers have examined the Tarantula Nebula's star-forming area. This 340 light-year mosaic image reveals countless previously hidden infant stars. Pale blue, massive young stars dominate the most active zone, while red stars remain embedded in the nebula's dust. Thanks to its exceptional near-infrared resolution, the NIRCam, near-infrared camera, can detect these dust-covered stars. An older star near the cluster of young stars and the amorphous cavity shows NIRCam's 8 diffraction spikes. The top central spike of the star almost points to a nebular bubble, which is being blown by young stars surrounded by dust as they carve out their own cavity. Astronomers have analyzed this area using 2 of Webb's spectrographs to identify the chemical composition of the stars and gas. From its spectral data, they can determine the nebula's age and the number of generations of star births. As cooler gas is pushed further from the hot infant stars, the nebula becomes rich in complex hydrocarbons. This dense gas will give rise to new stars, as gas and dust from giant star winds accumulate and, under gravity, coalesce to form new stars. A multi-wavelength view of NGC 1300. This image of the spiral galaxy NGC 1300 combines different observations to highlight star populations and gas. Yellow highlights, resulting from radio light collected by the Atacama Large Millimeter/Submillimeter Array, ALMA, emphasize the cold molecular gas clouds that serve as the starting point for star formation. Data from the Multi-Unit Spectroscopic Explorer, MUSE, on the Very Large Telescope, shown in red and magenta, reveal how young, massive stars affect the surrounding gas. The James Webb Space Telescope captures dust paths in gold and very young, bright stars in blue using images taken in the visible and ultraviolet spectrum. By using high-resolution infrared images from the Webb Space Telescope, researchers can pinpoint the earliest stages of star formation within this galaxy. Fomalhaut and Fomalhaut b, the newly discovered planet, is shown orbiting its parent star in this image from the advanced camera on board the James Webb Space Telescope. The small white box at the lower right pinpoints the planet's location. A 34.5 billion kilometer wide ring of dusty debris surrounds Fomalhaut and its companion. Fomalhaut b has carved a path around the inner edge of this ring. Fomalhaut b is situated 17 billion kilometers from its star and is located 3 billion kilometers within the inner edge of the ring. Astronomers have calculated that Fomalhaut b completes an orbit around its parent star every few years. The location of the star is shown by the small white dot in the center of the image. To observe the faint planet, astronomers use the coronagraph on the advanced camera to obscure the area around Fomalhaut. Fomalhaut b shines 100 million times fainter than its parent star. Scattered starlight creates the radial streaks, and a background star is indicated by the red dot at the bottom left. The Fomalhaut system is found in the constellation Piscis Austrinus, 25 light-years from Earth. The Southern Ring Nebula. This image of the Southern Ring Nebula, also known as NGC 3132, was taken by the James Webb Space Telescope's near-infrared camera and mid-infrared instrument. For comparison, the north and east compass arrows are used to determine the image's orientation relative to the sky. Note that the direction arrows on the ground are positioned counterclockwise with respect to the sky as seen from below, while, as seen from above, the directions align with those on Earth. As one would see from Earth, light travels at the speed of light. The scale is marked in light years. In roughly a quarter of a year, light would have traveled the length of the bar. The distance between 2 points on Earth, measured in light years, is approximately 5.884 trillion miles. MIL, 9,464 trillion kilometers, a fourth of a light year, is portrayed here. Tones regularly imperceptible at close and mid-infrared frequencies are displayed, showing which NIRCam and MIRI channels captured which shades of light using this helpful color key. The infrared light detected by each channel is named after the visible light tint it most closely resembles. The dwarf galaxy WLM, located 3 million light-years from the Milky Way, serves as an exceptional research site for understanding galaxy formation and evolution since it may have remained undisturbed by interactions with other systems. The presence of the Milky Way affects many nearby galaxies, making WLM a unique case. Interestingly, WLM's gas composition resembles that of early universe galaxies, with a chemically depleted nature and fewer heavy elements. Cosmic winds have caused the loss of many of these elements over cosmic time. WM has formed stars, which in turn have synthesized new elements. However, when massive stars explode, some of this material is expelled from the galaxy, a phenomenon also observed in galaxies like WM affected by supernovae. WLM is intriguing because it offers insights into the formation and evolution of stars in small galaxies similar to those found in the early universe. Approximately 12.7 billion years ago, our Milky Way galaxy was in its infancy. At that time, the sky was dominated by globular star clusters rather than the grand spiral arms we see today. The blue star cluster in the upper left is one of many primordial globular clusters that eventually merged to form our galaxy. This cluster can still be seen in the Scorpius constellation as the globular cluster M4. Astronomers use the Webb telescope to identify the cluster's oldest, faintest residual stars known as white dwarfs. The temperature of these dwarfs determines the cluster's age. This artwork depicts the cluster filled with young blue-white stars, likely forming around 100 million years after the Big Bang. The dense core of the galaxy is visible to the right of the center, where a nascent supermassive black hole is surrounded by dark dust lanes. The young black hole is consuming stars, gas, and dust while emitting a powerful jet of material through space. Pink bubbles of hot gas form around each star cluster due to supernova explosions from the most massive stars in the cluster. NGC 363 is a starburst region and a massive cluster factory, characterized by its unusually active star formation. As the closest region of its kind in our galaxy, found roughly 22,000 light-years from the Sun, it provides scientists with a local testing ground to study the intense star formation processes commonly seen in distant galaxies that are challenging to analyze in detail due to their great distances. Located in the Carina Sagittarius arm of the Milky Way and about 20,000 light-years from Earth, NGC 363 houses a cloud, within which HD 9795 can be found, an exceptionally dense open cluster, possibly a superstar cluster, nestled in a large HII region. New life in old clusters. This image from the James Webb Space Telescope shows the Milky Way's oldest globular cluster, M5. Although most of its stars were formed over 10 billion years ago, some surprising newcomers have breathed new life into this ancient population. Stars within globular clusters evolve together. The most massive stars exhaust their fuel in under 1 million years and end in supernova explosions. Consequently, the ancient cluster M5 should contain only old, low-mass stars that have aged and cooled into red giants and blue horizontal branch stars. However, astronomers have discovered a number of young blue stars within this cluster, intermixed with the older, brighter stars. They believe these blue stragglers were created through stellar collisions or mass exchanges between binary stars in densely populated globular clusters. In clusters with a few million stars, such events are possible. In NGC 346, Incredibly young stars have been observed spiraling into the center of a massive star cluster in the Small Magellanic Cloud, a satellite galaxy of the Milky Way. This puzzling discovery involves the large stellar nursery known as NGC 346, which has an intriguing structure and may be promoting new star formation through a stream-like migration of gas and stars. The spiral arm near the galaxy's edge could be driving this activity, according to research findings. This is an effective mechanism for nurturing star development. In a mesmerizing image, turquoise-tinted plumes, aquatic currents, and wispy tendrils extend from the luminous plumes, creating the illusion of an underwater scene. This photograph showcases the outer reaches of the Tarantula Nebula located within the Large Magellanic Cloud. However, this is not an actual ocean. The image captures a portion of the Large Magellanic Cloud, LMC, a neighboring dwarf galaxy orbiting the Milky Way. The LMC appears as a faint, fuzzy mass to the naked eye, but this captivating photo reveals the beauty hidden within its turquoise-tinted plumes. A cosmic tadpole, LIDA 36252, also called KISO 5649, is a small galaxy captured in this new image from NASA's James Webb Space Telescope. Due to its bright head and elongated tail, this galaxy is classified as part of a group of objects known as tadpoles. Found around 80 million light-years away, this galaxy is relatively close to us. While tadpole galaxies are rare in our corner of the universe, they are quite common in the wider universe, suggesting that many galaxies go through this stage during their development. Cosmic Center, infrared light from NASA's James Webb Space Telescope reveals the hot gas whirling around the area of the Smoothway universe's really monstrous dark opening. This 2009 picture was the most honed infrared perspective on the cosmic focus at any point caught, delivered to praise the worldwide year of cosmology. The James Webb Space Telescope, created by NASA, will proceed with this exploration with upgraded infrared location abilities and goal practically identical to Hubble's. Of specific interest to cosmologists will be Webb's perceptions of flares in the locale, which have not been distinguished around some other very huge dark opening. Webb's infrared information is expected to enormously help with getting a clearer picture, which has been obstructed by flares. In the Event Horizon Telescope's cooperation work to capture the region quickly encompassing the dark opening, Strange Mass Guide CL0024+17 is a universe bunch situated in the Pisces group of stars, around 4 billion light-years away. Cosmologists concentrate on CL0024+17 to all the more likely comprehend the dispersion of dull matter in the universe. Non-cluster systems, showing up as blue smears close to the picture's middle, are situated at a huge span. The extended and turned light from these far-off systems can be made sense of by gravitational lensing, brought about by areas of strength for the mass of CL0024+17. Dull matter neither emanates nor reflects light, making it undetectable to the unaided eye. Astronomers depend on the impact of gravity on light to distinguish it. By planning the gravitationally distorted light, analysts can follow the distribution of dim matter in the bunch. In doing so, they have found a dull matter ring around the group's center. Although this finding has been questioned by other independent investigations, the possible discovery of the ring remains one of the most powerful pieces of evidence supporting the existence of dark matter. Mists on Titan. On Saturday, November 5th, a gathering of planetary researchers from around the world woke up to the thrilling news that the principal Webb photos of Saturn's biggest moon, Titan, had been delivered. Connor Nixon, the dependable time perceptions head specialist, and the remainder of the Webb colleagues who are concentrating on Titan's current circumstance and atmosphere shared their preliminary impressions of the discoveries. Titan has a rich atmosphere and is the only moon in the planetary group with running liquid, other than on Earth. As opposed to Earth, however, the fluid on Titan's surface is made of hydrocarbons like methane and ethane, instead of water. Weighty dimness penetrates the environment, shutting out any daylight that could otherwise reach the surface. An eye overhead, this brilliant haze of gas and residue encompassing a planet, captured by the NASA/ESA James Webb Space Telescope, shows the dynamic gas cloud in NGC 3918 in the group of stars Centaurus, arranged around 4,900 light-years from Earth. The like design of NGC 3918 consists of a radiant internal shell of gas and a more scattered external shell, reaching out from the cloud. This may have been formed by two distinct gas discharges. However, observations of the object show that the two shells were formed simultaneously but are creating distance from the star at different speeds. Apparently, the giant planes of gas ejecting from the massive structure's edges are moving at speeds of up to 350,000 kilometers per hour as they leave the star. A grandiose couple, the NASA/ESA James Webb Space Telescope, captured this picture of the twisting universe NGC 1317, situated in the group of stars Fornax, more than 50 million light-years from Earth. NGC 1317 is part of a parallel system, alongside NGC 1316. However, the larger and more turbulent NGC 1316 isn't visible within the scope of Webb's telescope in this image. NGC 1317 is joined by two objects from vastly different regions of the universe. Regardless of the shortfall of its adjoining galaxy, the brilliant point surrounded by diffraction spikes is a star inside our own universe, while the redder, lengthened smear represents a far-off universe, a long way past NGC 1317. Complex dark beams. Nightfall offers probably the most staggering perspectives on the sky, as the sun's beams channel through clouds, creating a lovely mosaic of light and shadow, resulting from atmospheric scattering and cloud shadows. Another picture from the NASA/ESA Webb Space Telescope inspires a similar sensation as astronomers observe the nearby galaxy IC 563. In this case, slender, brilliant beams and dark shadows stretch across at least 36,000 light-years from the strongly glowing center of the dynamic universe. Specialists have followed the beams back to the universe's center, where a very huge dark opening is actively feeding. As the dark opening consumes matter, the surrounding superheated gas ejects in a stunning display of light. Specialists have proposed numerous clarifications for the peculiarity, with the most enthralling idea being that the shadows are projected into space by a torus of dusty debris orbiting the dark opening. Pillars of Creation. The mid-infrared Pillars of Creation picture, captured by NASA's James Webb Space Telescope, is tormenting. This district showcases the birth and death of thousands of stars in the midst of an ocean of gas and residue. Webb's mid-infrared instrument, MIRI, focuses on identifying dust, which is significant for star formation. The enormous blue-dark support points in the picture are the birthplace of various stars. Thick bunches of gas and residue within these regions break down under their own gravitational attraction, heat up, and lead to new stars. The picture reveals two kinds of stars: those within the thick, dusty support points, which have recently disturbed their surroundings, and their dusty environments give them a ruddy tone, and the more mature blue stars, which have lost most of their gas and material, making them appear blue. While stars are present in the picture, they produce little mid-infrared light and are better detected using UV, visible, and near-infrared light. Tarantula Cloud. The Tarantula Cloud star-forming region is brightly illuminated by Webb's near-infrared camera in this 340 light-year mosaic, revealing several huge numbers of previously hidden infant stars. The most dynamic region features light blue, massive, youthful stars, while the red stars remain embedded in the cloud's residue. Webb's remarkable near-infrared goal enables it to identify these residue-covered stars. A more mature star near a cluster of youthful stars in the shapeless pit shows 8 diffraction spikes in the near-infrared image. The top central spike of this star nearly points toward a cloud bubble, which is being passed up, youthful stars, surrounded by dust, to make their own pits. Stargazers have examined this area using 2 Webb spectrographs to determine the chemical composition of the star and gas. The spectral data assists space experts with determining the cloud's age and the number of generations of star formation it has gone through. Farther from the hot infant stars, the cooler gas in the cloud becomes corroded due to its lavishness in complex hydrocarbons. This thick gas will eventually lead to new stars. Gas and dust from the winds of giant stars will gather and, under gravity, form new stars. A multi-frequency perspective of NGC 1300. This picture of the twisting galaxy NGC 1300 combines numerous observations to showcase its star populations and gas. The picture highlights the bone-chilling submolecular gas clouds that act as the birthplace of stars, visible in yellow through radio light, captured by the Atacama Large Millimeter/Submillimeter Array, ALMA. A throbbing heavenly artifact, this shocking picture from the James Webb Space Telescope shows the planetary nebula NGC 2452 in the southern constellation Puppis. When a star like our Sun runs out of fuel, all that is left is a blue dimness across the whole screen. A star's atmosphere is blown away into space when the star's core becomes unstable and produces a surge of incredibly high-energy particles. The remains of the star that made this cloud can be found at the center of the blue cloud. At the center of the cloud lies a cold, weak, and extremely small star, which is technically known as a throbbing white dwarf. Due to the gravitational waves that pulse throughout its small star body, the nebula is pulsating. NGC 346. This picture of NGC 346 was captured by NASA's James Webb Space Telescope's near-infrared camera, found 200,000 light-years away. NGC 346 is a young star cluster inside a cloud. Webb's picture reveals a greater stock of building blocks than previously suspected, including mists rich in dust and hydrogen, which can be used not only to make stars but also planets. The gaseous crests and arcs in the picture contain both molecular and atomic hydrogen. The pink gas represents vigorous hydrogen, which can reach temperatures of up to 18,000 degrees Fahrenheit, while the orange gas represents dense atomic hydrogen, which is much colder at temperatures of -2,200 degrees Fahrenheit or below, along with the dust normally found with it. As stars form in the cooler gas, they change their general environment. The effect of the light from these youthful stars dispersing the thick mists is visible as various edges throughout the picture. The radiant gas support points are a demonstration of the boundless impacts of this heavenly disintegration. Magnetic beast NGC 1275. This unbelievable picture of NGC 1275 captures the ruddy, lace-like filamentary arrangements that surround its brilliant central region with amazing clarity and resolution. Despite being surrounded by gas that is almost 55 million degrees Celsius hot, these fibers remain cool. They showcase how power from the black hole at the center is transferred to the surrounding gas and held in place by a magnetic field. For the first time, space experts were able to assess the strength of the magnetic field by observing the filamentary structure. Using this data, they showed that the design of these fibers has been preserved over their 100-million-year lifetime by the extra cosmic magnetic fields, shielding them from breakdown due to gravity forces or the violence of the surrounding group. Infrared picture of NGC 1512. NGC 1512 is a barred spiral galaxy situated in the Horologium constellation, roughly 38 million light-years from Earth. This galaxy shows two concentric rings, an atomic ring surrounding the galactic center and an inner ring expanding outward from the main disk. Inside the galaxy's extensive UV plate, there are no less than 200 clusters showing dynamic star formation within the last few million years. NGC 1512 belongs to the Dorado group, a cluster of galaxies that includes several notable members. EL 2218. The picture shows EL 2218, a dense galaxy cluster consisting of thousands of distinct galaxies, located around 2.1 billion light-years from Earth. It resides in the northern constellation of Draco. Astronomers use this cluster as a powerful gravitational lens to amplify distant galaxies, enabling them to observe deep into the universe. However, this process not only enhances the pictures of obscured galaxies but also distorts them into extended, thin arcs, revealing the bending effect of gravity. NER 18. NER 18 is an experienced open cluster of stars that has already scattered into its birthplace cloud, representing the outcome or late stages of the star formation process. In the middle area of the picture, inside the cluster's bottom left corner, an infant star can be seen breaking free from its dense cover of gas, providing insight into the ongoing star formation process. Dynamic star nurseries can also be seen to the left of the picture. NER 18 is home to about 50 stars, some of which are extremely massive and short-lived. The massive star FM 3060A is still encased in a thin, dense hydrogen shell. At its current speed of development, its diameter will expand to about 2.5 light-years in the next couple of billion years. The cluster is located 26,000 to 35,000 light-years from Earth. Snakes and stones. The James Webb Space Telescope has provided a new perspective on the galaxy merger previously known as NGC 4194, revealing two distinct objects in the past. A gas-rich system was consumed by a galaxy, resulting in the release of intense jets of dusty gas and stars. This event has been compared to the writhing snakes that the legendary figure Medusa wore on her head. These snakes can be seen extending from the top of the merging galaxy, while the central region of the galaxy is compared to Medusa's eye, the safest area to observe the impact. The accumulation of cool gas has triggered explosions of star formation in this region, making it an eye-catching feature of the galaxy. Red giant blows a bubble. This dazzling picture captures a red giant star surrounded by a thin layer of gas. The star, known as Camelopardalis, or Yucam for short, is becoming increasingly unstable as it runs out of fuel. Over a few thousand years, it releases an almost round shell of gas as the helium around its core begins to fuse. The weak gas bubble surrounding the star in this picture shows the area of the gas expelled during the latest eruption. Despite its apparent closeness to the northern celestial pole in the constellation Camelopardalis, the star is relatively small and can easily fit into a single pixel. However, its intensity is too powerful for the advanced camera to handle. And that's all for our journey through the wonders of space with the James Webb Space Telescope today. I truly hope you enjoyed learning about the various galaxies, clouds, and stars that make up our universe. If you want to see more space adventures, be sure to hit that like button and subscribe to our channel. And don't forget to click on the video on your screen for another exciting journey through space. Who knows what amazing sights we'll discover next? Thanks for watching.